Morning, everybody. Next topic is the synthesis of the ammonia. And the ammonia is prepared laboratory by using the two different method. First is by the heating the ammonia salt with a strong base. So, which is prepared by the heating the mixture of the ammonium chloride and slaked lime. So the ammonia which is produced is dried by the passing it through a tower packed with quicklime, and it is then collected by the downward displacement of the air. And next method is the action of the water on metallic nitride, in which magnesium nitride, aluminum nitride or calcium nitride is treated with hot water and ammonia is formed. Next method is a very important method, that is the Haber process. Haber process, in which the combination of the nitrogen and hydrogen in the presence of iron or iron oxide catalyzed by the small amount of the potassium oxide or aluminum oxide at 450 to 500 degrees Celsius under the pressure of about 100 to 1000 atmospheric pressure. So, according to the Joule-Thomson expansion, which we studied in the thermodynamics, if you are compressing the gas at a very high pressure, then we are releasing or expanding, it will cool and we will get the gas in the form of the liquid. So, according to Joule-Thomson effect, the ammonia is produced, and here the formation of the ammonia is according to the Le-Chatelier principle. We have already studied the Le-Chatelier principle. So the favorable condition for the ammonia preparation is the increase of pressure and low temperature. If you are increasing the pressure, normally according to the Le-Chatelier principle, the formation of the ammonia is increased, and low temperature is required for the favorable preparation of the ammonia, because this is an exothermic reaction. So the temperature here used is 450 to 500, and 450 is the optimum temperature for the catalyst, which is used to get the relative better yield of the ammonia. Next, we are moving into the structure of the ammonia. As we know that the ammonia having an sp3 hybridization state, and there is a one lone pair of electron in the nitrogen, and due to the presence of the lone pair bond pair repulsion is existing, and so there is some deviation in the bond angle of the sp3 hybridization. So actual bond angle is 109, but here the bond angle is 107.8 due to the bond pair lone pair repulsion. So we can avoid the lone pair of electron while we are predicting the structure. So that's why the ammonia is existing in a triangular pyramidal structure, and we having the bond angle of 107. And next is the properties of the chemical properties of the ammonia. As we know that the ammonia is a weak base, and it forms the precipitation of the hydroxide. This is an important test for analyzing or to identify the zinc, aluminium and iron. If you are treating the ammonia with the salt solution, ammonia solution with the salt solution of these metals, we will get corresponding hydroxides. So this is an important test for the identification of the zinc, aluminium and iron. Next is the complexing property. Ammonia is acting as a ligand, so that's why it is a good Lewis base due to the presence of the lone pair of the nitrogen. So that's why the ammonia will give its lone pair of electron to the Lewis, the electron deficient species, especially for the BF3. And when the aqueous ammonia is added dropwise to the cupric salt, a pale blue precipitate, which is shown in the slide, a pale blue precipitate of cupric hydroxide is formed first, which is dissolved in excess solution of the aqueous ammonia to give a deep blue solution due to the formation of the tetra amino copper 2 cation. So this is an example for the complexing effect of the ammonia. And and we have to this is the one of the experiment which we have to done in our third year practical for the preparation of the inorganic complexes. So next is the Nestless reagent, action with the Nestless reagent, which we have already studied to this method for the identification of the ammonia while you are doing the practical in plus 2 classes. So the Nestless reagent is the K2HgI4. So when the ammonia react with the Nestless reagent, we will get the brown colored precipitate which is shown in the test tube. This is the molecular formula of this brown color precipitate NH2HgOHgI. So this is a very important test for both the qualitative analysis. The equation is very important, Nestless reagent formula is very important, and the result is also important for your analysis. Next is the reaction with halogen, and the ammonia react with halogen to form the ammonium halide, and similarly action with alkali metal. The ammonia react with alkali metal and to form the corresponding amide, and the oxides formation, ammonia react with oxygen to form the NO and water. So next is the important uses of the ammonia. Ammonia is used in the nitrogenous fertilizers and manufacture of the nitric acid. It is also used in the qualitative and quantitative analysis, and the liquid nitrogen is used as a refrigerant and non-aqueous solvent. Thank you.